Hello, Science 10, and welcome to the second video on our lessons on significant digits and scientific notation. We are now going to start speaking about scientific notation and what it is and how we use it. This is really commonly used, especially in physics, as a way to express numbers that are really big or really small. So let's get started in with how do we use scientific notation, where do we use it, and why, okay? So why do we use it? Well, I kind of already told you. It's essentially a way that we want to take really big numbers or really small numbers and write it in a way that we can use it. All right. So a way that is a lot more accessible and understanding than having a number that has 12 zeros behind it or 6 zeros in front of it. So how do we do this? Well, we always have to take our number, whatever number we're given, and we have to create a number between 1 and 10. Usually it's going to be some sort of decimal number. So if I gave you a number like 182, that is not a number between 1 and 10. So you would say, well, the number between 1 and 10 would be not 18.2, but 1.82. Now, that's a whole different story than 182. 1.82 is not 182. So there's more to the story on what we do with scientific notation. And that is called using the power of 10 to express how big or small it is. So every single time you use scientific notation, you create a number that's between 1 and 10. And then by using the power of 10, which I'll show you what that looks like, you're going to express if it's a really big number or a really small number. So in your notes, here are some examples. So if I have 4,159.25, that's a really big number. It's not something we can't read, but maybe we would really like to use it in a smaller version. Now, I've included all digits here, but based on our significant digits lesson, if this was adding, we might only use two significant digits, like 4.1. If it's multiplication, it might be using all digits. All right. Now, what scientific notation does is it takes it and we take that number and we put it into a form that is between 1 and 10. So here is my number. I'm going to make this number into a digit between 1 and 10. So 41 is not a digit between 1 and 10. 415, none of that. The decimal has to go between the 4 and the 1 because that makes it between 1 and 10. So here it is, the 4.1. But again, 4.1 is very different than 4,159. So what I have to do is when I take this decimal and move it, I have to count how many spaces I moved it. So in your mind, think, okay, I'm going to move the decimal place 1 to between the 5 and the 9. I'm going to move the decimal place a second time between the 1 and the 5. And I'm going to move the decimal place one more time, so 3 times between the 4 and the 1. So then I write my number 4.15925, and I say multiplied by the power of 10. So you'd write 10, and then how many times you moved it. How many times you moved that decimal. So I moved that decimal 3 times. 1, 2, 3. So it's 4.15925 times 10 to the power of 3. This little 3 has to be tiny and up top. That's superscript. Now, that's how you move numbers that are really big. Sometimes we have to move numbers that are really small. So again, here's my decimal place this time. I want to make a number between 1 and 10 every single time. So I'm going to look here and I'm going to put the decimal place right between this 2 and this 6 because that gives me a number between 1 and 10. Again, I have to just count how many times I move that decimal. So I'm going to look at this decimal. I'm going to, in my head, think, okay, I moved it once, and then I'm going to move it twice. So now it's 2.654 because there's a bit more. But because I'm moving the decimal place to the right and I'm making a very small number a bigger number because 0.02654 is not the same as 2.654. Instead of putting 10 to just to 2, I have to put -2. Because what that tells me is that my number was smaller than 1. And when I take it out of scientific notation, which I'm also going to teach you about, I know which way to move my decimal. All right. So let's really dive into this and let's talk about some examples. Okay. So if you have a number such as 526,201, you can put it into scientific notation. Why? Because it's a really big number and maybe we want to use something a little smaller. So step one is figuring out where's the decimal place. My decimal place would be after this one right here. This is a comma, it's not a decimal place. So I have to look at my whole number. My decimal would be here. I need to start by making a number that's between 1 and 10. So I do that. I make my number between 1 and 10. Now, I'm not taking into account, guys, significant digits at this moment. I'm just using the whole number just to give you guys an idea. But if you were using scientific notation in an assignment and it says to 2 significant digits, I would put this as 5.3, for example. Okay, so just be aware that I'm just teaching scientific notation. I've kind of left significant digits off to the side as a separate idea for now. So now I have a number that's between 1 and 10. So I now need to go times by 10 to what power? So I have to start by counting the spaces to the left that I have. So my decimal was here. I'm going to move it. 1, 2, 3, 4, 5 spaces. So I counted all the way up to my decimal and I wrote 5.26201 times 10 to the 5. Again, my 5 is positive because I had a really big number and I want to keep it big. I want people to know that it was a big number. So I moved my decimal places 5 spaces to get this number. Okay, so since it's a big number, 5, we leave it as positive. So if I moved it backwards, I would know that I moved it 5 positive spaces. So I'm going to move it back this way. Let's pretend we have a number that's something like 0.00526. Okay. Now, this is a good example of significant digits. I'm not going to count these zeros because they don't matter. They're not significant. So I'm going to make something that is between 1 and 10, which is 5.26. I have my number between 1 and 10. But again, this time, I have to remember that this number was less than 1 to start with. So when I move my decimal place, 1, 2, 3 spaces over, so I counted my decimal places to the right. When I moved them 3 spaces over, this time I have to use -3 because my number was so much smaller than the original number the number I have now. Okay. So if you think about a number line, like pretend you can see a number line here and zeros in the center. Okay. Everything on this side is negative. Everything on this side is positive. So if you think about moving something 5 positive spaces, we would move it to the right. And if we think about something moving down the negatives, we would move to the left. So if you think about it that way, that's why, okay? If we were to put this back into scientific, if we were to put this back into standard, we would move it 3 spaces left. 1, 2, 3. So it'd be 0.00526. Okay, that's why we use the -3 here. So since the number was smaller, we need to show that it was smaller than 1. So we use the negative sign to show that. All right. So let's see if we're understanding. We're going to do a couple of examples. I'm going to throw a pretty tough example at you in here, and then we're going to let you go and try and do some practice. Okay. So let's start by converting 0.003127 kilograms to scientific notation. So you're going to start off by reminding yourself, make a number between 1 and 10, count my decimal spaces. Okay. So what's your answer? And do you have a whole number? So a whole number would be a number between 1 and 10. And does your power of 10 show a negative number? Because if it does not, then you did not do this correct because this is smaller than 1. So your power of 10 has to show that it is smaller than 1 by using a negative number. So in the end, I'm going to get you guys to put your number in here. And in the end, you should have an answer. And you will find out what it is when you put your number in. Let's convert 1,564.7 meters to scientific notation, but this time with only 3 significant digits. Okay, so again, this one I said same number of significant digits. So this one had 4. This one is only going to have 3. Okay, so when I convert this, again, do I have a number between 1 and 10? Is it only 3 digits long? And now because it's a bigger number, my number is going to be, my power of 10 is going to be positive. So I want you to write that down and then enter your answer into here and see if you got it right. All right, so let's do some more examples. I'm going to walk you through these ones because these ones are a little bit more difficult. So this is what happens a lot of times, guys. Can you see convert 33 times 10 to the negative 3? The biggest mistake students make when making scientific notation is they do not make a number between 1 and 10. They just make a smaller number than what they were given or a bigger number than what they were given, but that's not between 1 and 10. So if you're given something like this on an assignment and it says convert it to scientific notation, you got to be really careful because this is not accurate. This is not showing 3.3. This is showing 33 times 10 to the negative. So what you want to do is you want to pull this out into a real number so you can see the decimals and all the spaces. So how I did that was I said this negative 3 represents 3 decimal places. It's negative, so my decimal places have to move to the left. So even though there's not a decimal here, that's where the decimal would be because it's showing 33 as a whole number. I would count 3 spaces. 1, 2, 3. Put my decimal down. Where there's a blank space, you would add a 0. So what I did is I took my decimal from here, moved it 3 spaces, added a 0 in because there was a blank space in front of that 3, and now this is my new number, 0.033. I want to take this and convert it into scientific notation. So now I'm going to go through the rules I already know. Make a number between 1 and 10. So I'm going to say 3.3 instead of 33. And I'm going to see how many times I move that decimal place. 1, 2. So in order to make this into proper scientific notation, it is actually 3.3 times 10 to the negative 2, not the negative 3. Okay, so here's my actual number. Again, I used negative 2 because this was smaller than 1. Now, when it comes to scientific notation, you're not always going to be asked to put things into scientific notation. Sometimes you're going to be asked to take it out of scientific notation and put it in what we call standard notation or standard form. So really all you have to do is, again, use your understanding of which ways the decimal moves and count. So if I look at this number here, again, someone made a mistake. This is not a number between 1 and 10. This is a number less than 1. So you're going to want to pull it out into standard notation. This is not correct. This right here is standard notation, what I did earlier. So let's fix this and then just leave it in standard notation because that's what it's asking. So because this says -4, I want to take this decimal and I want to move it 4 places to the left. 1, 2, 3, 4. So everywhere that there was blank spaces, every time I jumped, that jump meant that there should be a 0 added. So it looks like this. My decimal was right here, right where my cursor is showing. I jumped 4 spaces to the left. 1, 2, 3, 4. Everywhere from here to here, where the decimal place went, gets a 0 to hold that place. They're not significant digits, but we need to hold that place. All right, so this is what my number looks like in standard form or standard notation. So I moved the decimals to the left because it was a negative number. In this example, I want to take my 8.10 times 10 to the 2, and I want to know what it was as a standard form or standard notation. So again, I'm going to look, it was +2. So rather than moving to the left, I'm going to make a bigger number. So I'm going to move it to the right. So I move it from there and I count 2 spaces. 1, 2. So in the end, I get 810 because I moved it 2 spaces. I moved it from between the 8 and the 1. 1, 2, use the numbers that were there for me, and there's my whole number. So again, you have a big practice section in your book. Please practice and then check your answers and let me know if you have any questions. So between the 2 videos today, what did you learn? Okay, well, you learned that significant digits are there and you have to use different rules for different calculations. So how to count significant digits, What does it mean if there's addition and subtraction? And what does it mean if there's multiplication and division? You then practiced your understanding. And again, if you didn't do well in significant digits, please talk to me. Then we did showing us scientific notation. Scientific notation, again, you learned how to put it into scientific notation and take it out of scientific notation. And now you're going to practice your understanding. If you have any questions, ladies and gentlemen, please let me know.